Okay, everybody, welcome to this little catch-up video. I hope this isn't going to take too long, but I've had a few emails coming, well, a couple of emails coming in asking me or saying that you're still struggling to write half equations and you're even struggling with oxidation states. So the first thing I would do, I'd really encourage you've got to go and help yourselves a little bit first by looking back at the first videos on writing half equations and doing oxidation states, because imagine you're building a house, right? If you're building a house, you need really strong foundations. So these are the foundations for redox. If you can't write half equations in oxidation states, it doesn't matter really that you're learning all this other stuff about halide ions and halogens. You are always going to be living in fear of half equations in oxidation states because you didn't get it right at the time. So really, you should be going back to those early videos and looking through them again and getting your pen out. And when I say practice them, you have to practice them. All right, so what I'm going to do in this video is I'm going to go through some half equations in oxidation state stuff, but I'm going to link it to the halide ions with conc sulphuric acid stuff that was in my last video for you. All right, I'll also, because I've been asked to do it, I'll also be going through question 8 again, because one person requested that, so I thought I may as well. If that person misunderstood it, there'll be others. So, first thing I'm going to do then is draw this diagram. Now, you don't need to know how to write half equations to draw this diagram, but you sure as hell need to know how to write half equations if you're going to use this diagram. Now, that is really annoying, isn't it? Because I started too high up the page. Oh well. Sorry about that. These boxes are meant to be the same size. But anyway, I haven't got any notes with me. You've got to realise this. I'm doing this from memory. You need to do this from memory. All right? I'm not super duper brainy. I've just learned it and it's stuck, okay? So this represents chloride and fluoride, and this box represents the reactions that they do with H2SO4. This represents bromide ions, and these two boxes represent the reactions that bromide ions do with H2SO4. So fluoride and chloride do one reaction, bromide ions do two reactions, and iodide ions, being the best and the strongest reducing agent, do 1, 2, 3, 4 reactions. This bottom row is common to all three reactions. So what happens is if you take the sodium halide, the NaX, so that could be NaCl, NaI, NaBr, not aqueous, solid, and you react it with H2SO4, which is aqueous and concentrated, it turns into NaHSO4 plus HX and gives off misty fumes. I'm just going to write MF, misty fumes, for the observation. This is not redox. Something I didn't mention last time, well, if it's not redox, what is it? And the answer to that is it is an acid-base reaction. All right, that's what you'd write in the exam. It's an acid-base reaction. The acid is getting neutralized in a way, but that's how you. It's not redox, it's acid-base. The next thing that we do, the products of this reaction and this reaction, the sulfur products are the same. You make SO2, SO2, which is a choking gas. You make Br2, and in this case you make I2. So bromide, when it reacts with H2SO4, makes misty fumes, choking gas, and bromine. 1, 2, 3 products. Sodium chloride will make misty fumes because it just does this box. Iodide will make misty fumes, choking gas, iodine, which is a black solid, or purple vapor, whichever one you prefer. I'm going to go with black solid. It also makes S and I2 and H2S and more I2. Yellow solid, eggy smell, yellow solid. I can't wait to offend you all by doing that experiment in the class. It stinks, and I'm going to waft it around the room, and you're going to hate me for it. All right. So Now that I've got this here, this is not to do with half equations or oxidation states yet, but I'm going to use this as my sort of guide for today's lesson. Right, let's look at oxidation states. H2SO4 is one of the reactants in these reactions. The reactant for all of these reactions. So what's the oxidation state of sulfur in H2SO4? So this is for those people who said, I still don't get how to do oxidation states. Well, firstly, go back to that video that I said first time, and then look at this as well. So H2SO4, when you're working out an oxidation state of an element, it'll be the element that you don't really know the oxidation state of. So sulfur, I don't know its oxidation state because it can have a variable oxidation state. Oxygen, you know, is always -2 in a compound. You've got to learn those rules. So again, learn those rules. Each hydrogen in here is +1. So you should be able to work out by a process of elimination what the sulfur is. So I'm going to do it in my way, which again I've shown you on a video. I'm going to draw a number line. You won't need a number line necessarily. I've got 4 oxygens, and I know oxygens are each -2. So imagine this, I go -2, -4, -6, -8. And that represents, it's like a negative charge, a -2 on each oxygen, -2, -4, -6, -8. That's where my oxygens take me, so I've done that. I've got 2 hydrogens in there, each of which is +1. So I want you there +1, so they're going to go in this direction. +1, +1. Overall, this compound does not have any charge, so the sulfur, the charge or the oxidation state on the sulfur must be this difference, which is +6. Each oxygen is -2, which takes you to -8. Then you've got +2, which takes you back to -6. So sulfur must be +6 to give you an overall charge of 0. If it helps, just think of oxidation states as charges. These are, overall this is 0. So 4 -2s and +2, this must be +6. All right. So H2SO4, the sulfur is in oxidation state of +6. I'm going to write that over here. H2SO4, it's +6. In NaHSO4, the oxidation state is still +6, and I'm going to prove that to you now. NaHSO4, well, what have you got? You've got 4 oxygens. You've got 4 lots of -2. The oxidation state of oxygen is -2. So that will take you -2, -4, -6, -8. Okay, so I'm on -8 now because of my oxygens. I've got 1 hydrogen, which is +1. A sodium is a group 1 metal, and when a group 1 metal is in a compound, it'll be sodium plus, it'll be +1. It's one of your rules that you need to learn. So if you are that person or those people who said, I don't get oxidation states, learn those rules. Sodium is always +1 in a compound. Hydrogen is always +1 in a compound. Oxygen -2 in a compound. So that means I've only got the sulfur to take care of. The sulfur must be +6 to get me back to 0. So in NaHSO4, the sulfur is also +6. So that's how I can tell that this first reaction is not redox, because the sodium is +1, the halide ion is -1, hydrogen +1, sulfur +6, oxygen -2, sodium +1, hydrogen +1, oxygens are -2, hydrogen +1, halide ions in a compound are -1. The numbers on this side for the elements are the same as on this side, so there has been no reduction or oxidation. All right. SO2, however, the oxidation state of sulfur in this, well, I'm going to do it without the number line now. I've got 2 oxygens. That's -2, -4. The sulfur must be +4. Okay? So if I've gone from H2SO4 as a reactant and I make SO2, the sulfur has gone from +6 to, oops, I've just gone off the page there, to +4, which is called a reduction. It's been reduced, the numbers got smaller, that's a way to remember that. Alright, so there's SO2. So when sulfuric acid gets reduced, it turns into SO2. It can be reduced further to sulfur, which is an element in its standard state, and the rule for elements in their standard state, the oxidation state is 0. it effectively has got all the electrons. It hasn't lost or gained any electrons. And then finally, we've got H2S. Oops, H2S. Each hydrogen is +1. So I'm going to draw a number line. Each hydrogen is +1, +1, +1. There's 2 of them. So to get back to 0, the sulfur in this case must be -2. All right. So if we look at this diagram, what I'm saying here, chloride and fluoride, only what they do when they react with H2SO4 is they turn it into NaHSO4, which the oxidation state of the sulfur does not change. So it's not redox. Bromide, these are different colour. I've got some of my kids' crayons, the ones that you get from a Hungry Horse restaurant. You always keep hold of them. They'll come in useful one day. Bromide reacts with H2SO4. It turns the H2SO4 into NaHSO4, which is not a redox reaction, but it also turns the H2SO4 into SO2. So the H2SO4 turns into SO2, which goes from +6 to +4. It reduces the sulphuric acid. It reduces the sulfur in the sulphuric acid. So it's a reducing agent. Iodide is the best reducing agent because, well, not because of this one, because that isn't reduction, this first box, but it does this. It makes NaHSO4. But then it reduces the sulphuric acid to SO2, so from +6 to +4. It then reduces it to sulfur, to 0, so H2SO4 goes from +6, they're not that good, these crayons, to 0, and then also reduces it from +6 all the way to -2. So if you don't know how to do oxidation states, you haven't got a clue in understanding this. So go back to that video and learn your rules, because I absolutely promise you, it's really simple. And I promise you, if you come out in the exam next year and go, oh, I never got my head around oxidation states, you didn't work hard enough at it. And I'm afraid that's just the way it is, that some people will get it quicker than you, but you will feel so much pride in yourself if you get your head around it, because it opens up so many marks. All right, I teach students every single year who don't listen to these words of advice, but now I've got them on video so you can rewind them and rewind them and rewind them. Work hard and get the rewards, because you deserve it. You're all wonderful students and you've all got the capability. So don't look at somebody else and go, why do they always get it first? I don't care about that. I've seen what you can all do, and you can all learn these. You can learn how to assign oxidation states. The next thing then is half equations, and this is, again, one of those things that I'm going to insist that you get your head around. So don't worry, by the way, I'm not annoyed that you sent me an email saying I don't get half equations and oxidation states. I love it. I missed that from the lessons. You'd have just been able to tell me that in the lessons and I could have sat with you. So I'm glad that you're telling me. I really am. And I want to make this video. So, right, I'm going to draw my little diagram again. I'm going to draw it in blue felt tip this time because I want to. All right. What have we got here then? So I'm going to do NaHSO4. Blue felt tip was a bad idea. HSO4 plus HX, SO2, SO2, Br2, I2, S, I2, H2S, I2. All right. So what the examiner might ask you is they could ask you to describe any one of these boxes and write an equation for any one of these boxes. So say, for example, the examiner says, let's have a little look. I'll just write NaX H2SO4. So the examiner might be describing something where it says an eggy smell was produced. And let's go with this. A choking gas was produced when sodium iodide, a choking gas was produced when sodium iodide reacted with H2SO4, concentrated H2SO4. Or they might say when solid sodium iodide reacts with concentrated H2SO4. Write an equation for this. So you would go, right, okay, this is a conc H2SO4 halide question. So you'd think of this and go, right, what's the choking gas? And hopefully you realise that SO2 is the choking gas. Sodium iodide is referring to this column. So sodium iodide reacting with H2SO4 making a choking gas is asking you to write an equation to represent the changes in this box. Well, you could write an equation by going like this and saying NaI plus H2SO4 makes I2, because that's here, plus SO2. But the problem is you're not going to get the right answer very easily. So what we're going to do, and what you'll be doing on the papers, is if you think they're asking you about this diagram and they ask you to come up with an equation, you will firstly construct half equations and then construct a full equation. And I promise you that is quicker and easier than just learn the equation for this box, which is how a lot of teachers teach it. Just learn 1, 2, 3, 4, 5 equations. No, that's not a very good way of teaching it, I don't think. So I know that, so here's my approach, which is not this. I know that they're asking me about the formation of a choking gas using iodide. So I know that I've got my products in this box. My products are, for the half equations, remember, just think of like a half of anything. You're going to write 2 half equations and then join them together to become a whole equation. So half equations you make first, you balance them with electrons, and then you join them together to make a whole equation. So actually I'm going to do that. I'm going to draw 3 arrows. Half equation, whole equation. All right. So choking gas is SO2. And I know that SO2, the sulfur product, has come from the H2SO4. I hope you're all right with that. The reactant that made the SO2 was the H2SO4. By the way, that was plus 6 and plus 4. Doesn't help you with the half equations, but The other product is I2. And you think, well, what reactant was the I2 made from? Well, it's most probably going to be the iodide, isn't it? It is going to be the iodide. So what you've got to do first, so what a half equation does, so listen very carefully, especially if you struggle with these, a half equation tells the story of a reaction just by looking at one of the reactants. It tells you what one of the reactants turned into. The other half equation tells you what the other reactant turned into, and the whole equation will join those two together. So we've got H2SO4 turning into SO2. So there are some things that you had to do, and I labelled these in my first video. There's some series of rules that you've got to do. Firstly, you look at the element that you're interested in, the sulfur in this case, and you think, is that balanced? 1 sulfur that side, 1 sulfur that side. Yes, it is. It's balanced. Then you look at the oxygens to see if they're balanced. There are 2 oxygens on this side and there are 4 oxygens on this side. So we balance oxygens with water. These are rules. You learn these rules and you do exactly what I'm telling you. So there are 4 on this side, there are 2 on this side. So I'm going to need 2 H2Os. Okay? So now there are 1, 2, 3, 4 oxygens on this side. Next thing you do is you check the hydrogens. There are 4 hydrogens here and there are 2 hydrogens here. So you balance any hydrogens with H pluses. So there's 4 on this side, 2 on this side. So I'm going to need 2 H pluses. That was the next rule. And the final rule is to balance any charges using electrons. So I would do it like this on the first video and go, on this side the overall charge is 0 because there's no charges. On this side the charge is plus 2. So I need to add electrons to one side to make them equal. Now if I add 2 electrons onto this side would be 2 minus and this would be 2 plus. That's not the same. Alright, 2 minus and 2 plus are not the same. But if I add 2 electrons onto this side, I've got 2 pluses and 2 minuses which cancel each other out. So that's 0 charge on this side, 0 charge on this side. That half equation is done. I minus into I2. The first rule is balance any elements that you can, right? Done. Balance any oxygens with water. There's no oxygens in this half equation. Balance any hydrogens with H+. There's no hydrogens. Balance any charges with electrons. There's 2 minuses on this side, so I'm going to put 2 minuses on this side. Without me talking through this, it's an incredibly quick process. Okay? So, the next thing to do there, my 2 half equations, I need to join these 2. Remember what I said? Construct the half equations, construct the full equation. So from the equation, we've identified the box, we construct the half equations, then we construct the full equation. And doing it once ain't going to do it. Do it again and again and again and again. For every single box, do it again and again and again and again. All right, I ain't going to want to explain this to you many, many times if you're not willing to put the practice in. All right, to join these two together, you look to see how many electrons are in each half equation. In this half equation, where this is gaining electrons, by the way, if it's gaining electrons, that's the reduction half equation, because reduction is gain. This must be the oxidation half equation, because oxidation is loss. 2 electrons are gained, 2 electrons are lost. They don't need anything doing to them, so you don't need to multiply any of these. We're going to do some more examples in a minute where you do. So, all I've got to do is put these 2 half equations together. So there's my arrow in the middle. So the products are all of these, where you've got 2 H pluses. The electrons cancel with those electrons. You've got H2SO4, and you've got 2 I minuses. That's that one, and that one done. And you make SO2 plus I2 plus 2 H2Os. Done. That's how you write it. All right? So, I'm going to do another one. Imagine that the examiner says a solid sodium halide was reacted with conc sulphuric acid. You listen to that? A solid sodium halide was reacted with conc sulphuric acid. So you're thinking, it's this diagram. An eggy smell was produced. So you go, that box. That's the only box that makes an eggy smell. So the solid sodium halide must have been NaI, and it makes this eggy smell. And a black solid, this is a black solid. Write an equation for the formation of this eggy smell. Okay, so what I'm going to do, write an equation. Firstly, half equations, then full equation. 1, 2, 3 arrows. You know what? I'm going to do the full equation in a different colour. My half equations are going to be green. The full equation is going to be black. All right. So all you got to do, you remembered this box because you've done a bit of learning, and you remember that it's got H2S in it and I2 as the products, this one and this one. What does H2S come from? Well, it comes from H2SO4. Where does iodine come from? Well, it comes from iodide. Let's get to work on this. 1 sulfur, 1 sulfur. Don't need to do anything. 4 oxygens, I need 4 H2Os to balance the oxygens. Now I look at hydrogens. 8, 9, 10 hydrogens on this side, 2 hydrogens on this side. I need another 8 H pluses on this side. Charge, no charge on here, 8 plus on this side, so I'm going to need 8 electrons on this side. That is done, 1 half equation. I2, I minus, I'm going to need 2 of these, I'm going to need 2 electrons to do that. That's done. What I now need to do is join these 2 half equations together, so listen carefully. 8 electrons in this half equation. 8 electrons are gained. Each sulfuric acid is gaining 8 electrons, but in this half equation, it's only making 2 electrons. So we need to make these balance, because if 8 electrons are gained, 8 electrons must be lost. That's the reason why. So I'm going to multiply this bottom half equation by 4. If I multiply it by 4, that will give me 8 electrons, 4 of these, and 8 of these. I've multiplied everything by 4. Now I can join them together. So I've got, the electrons have cancelled. 8 H pluses, that's you. H2SO4, that's you. I'm ticking them so I don't miss them. 8 I minuses, that's you. And it makes eggy smell, H2S, that's you. 4 I2s, that was you. And 4 H2Os. So in the examiner, listen to this really difficult question again. When concentrated H2SO4 was reacted with a solid sodium halide, an eggy smell was produced. Write an equation for that. Now, you'd have gone, I have no idea what he's on about. And now hopefully you go, eggy smell, your box. All I've got to do now is write 2 half equations, H2SO4, I minus, balance them with water, balance them with H plus, balance them with E minus, join them together, and you've got a mark that not a lot of people are getting. This is not an easy topic. All right, which now brings me to question 8, because I've been asked by students to just go through question 8a again. Where were you? Right. Sorry, I've still got my writing on it here from last time. I should have printed off another copy, but I didn't. So, sodium bromide reacts with concentrated sulfuric acid. in a different way from sodium chloride. All right, so this is comparing sodium bromide's reactions with conc sulphuric acid to sodium chloride's reactions with conc sulphuric acid. So the bit of the diagram that I'm interested in is sodium chloride and sodium bromide. It's not asking me about iodide. Let's read it again. Sodium bromide, which is Br minus, there's sodium there, but it's a spectator ion, reacts with conc sulphuric acid, so it's this diagram, in a different way from sodium chloride. All right, write an equation for this, and this is the one I got asked the question about. So it reacts in a different way. Well, they both react in this way. And this way is the way that you would get, so NaCl reacts with H2SO4 to make NaHSO4 plus HCl. And NaBr reacts with H2SO4 to make NaHSO4 plus HBr. That is reacting in the same way, in the non-redox way. The question says sodium bromide reacts in a different way to sodium chloride. They are referring to this box, which bromide does, but look there, chloride doesn't. So bromide, they both react to make misty fumes, but bromide reacts to make SO2, choking gas, and bromine. So the question is saying, bromide reacts in a different way to chloride, write a reaction for this equation. So we know we're dealing with this box, so then what do? Well, we start off by writing half equations, and then we can turn it into a full equation. So 3 arrows. I know SO2 is formed, and I know Br2 is formed. See, chlorine doesn't do this. Chlorine does not act as a reducing, chloride, does not reduce sulphuric acid. It just does this bottom reaction. It doesn't do this, it doesn't do this, it doesn't do this. So then I'd write what the reactants were, which is H2SO4 and Br minus. So 1 sulfur, 4 oxygens, 2 oxygens. So I'm going to need 2 H2Os, 4 hydrogens, 2 hydrogens. I'm going to need 2 H pluses, and I'm going to need 2 electrons there. Bromide, 2 of them, plus 2 E minus. Notice how when you practice these, it's just like, you know you're getting them right. So I don't want you to just sit there, watch this and go, get your pen out and do it yourself. All right? If you don't do that, 1, you're being lazy. 2, you won't ever reach your potential. All right? You should see the piles and piles of paper that I go through when I practice these things. All right? And they are easy. I'm sorry when teachers say things like, it's easy that. I know, right? It's easy when you do the work. It's like when you see kids riding around the streets on here doing wheelies on the bike. And they go, that looks really easy. Have you ever tried the wheelie? It's really difficult. All right, it wasn't all just so I could say that. But it is, you practice something and it becomes easy. All right? You want this to be easy, don't you? So get your pen out and do it. Write an equation for this box, this box, this box, this box. Do them all. Learn this equation. Memorize it. You've got time, haven't you? There's no school on. All right, so last thing to do, there's 2 electrons here and 2 electrons here, so they don't need any multiplication of any of these. All I have to do is join them together. That's 2 H pluses, H2SO4, 2 Br minuses, SO2, Br2, 2 H2Os. Just check, I've used you, I've done you. That's the overall equation. So to that person who asked me, I hope that makes it clear. I hope that's useful for you. And to those people who asked me about oxidation states and half equations, remember where we started today? It was here, oxidation states and half equations. So there's some work on oxidation states down here. You've got to learn the rules on those. Here's a couple more just before I go, because I may as well make it up to 30-minute video. Here's some oxidation states that are a little bit trickier. So here's an element in its standard state, Cl2. HClO, you'll come across that when you did reactions of chlorine in water. Right, here's Cl2. Chlorine in Cl2 is 0 because it's the element. Chlorine in HCl. Hydrogen is +1 in a compound. Chlorine in a compound is -1. Normally, chlorine is -1 in a compound. All right, but this one often catches people out because you go, oh, no chlorine, that's -1. Not in this case. Oxygen is one of the main rules, -2 in a compound. Hydrogen, +1. The chlorine in this case, -2 plus 1 is +1. All right. So, for example, so there's some other oxidation states. Go and practice them. If you think I want more practice, Google oxidation state practice. I don't know. All right, you've got my resources. There's plenty of others. There's a whole world of them out there. There was something else I was thinking. I was going to do something and it was going to be useful. And I can't remember what it was. And I'll remember as soon as I stop this camera, won't I? This is a good bit of the video, isn't it? You enjoying it? I am. I've done that. I've done oxidation states. I've written half equations. Was it something else that somebody asked me? You know, that's going to frustrate me, that, because I'm not going to remember it. Nope, it's gone. So I might have to put it in an email or something. I hope that was useful. And this video has been made because you send me those really important emails that give me feedback and they tell me things like where you're struggling. So I know I have a little shout at you, like, but you know me fairly well, and you know that I just really want to help you. So I hope that's useful for you. I hope that helps you get on the right track. Yeah, and keep in contact, please. See you later.